The equation we will be solving today is y equals x over x squared minus 4. We will be solving for the domain, range, intercepts, symmetry, any asymptotes, the end behavior of the graph, any intervals, local max and local min, the concavity of the graph, and any inflection point. The first thing we'll be solving for is the x and y intercepts. So to start, you're going to want to plug in 0 for x into the equation. So you're going to have y equals 0 over 0 squared minus 4, which equals 0. Then you're going to set that equal to y, which equals 0, 0. To solve for the horizontal asymptote, you have to look at the ratio of the exponents in the equation. As the bottom exponent is greater, the horizontal asymptote equals 0. Now for vertical, you want to set the bottom of the fraction equal to 0, and you'll get x plus 2 and x minus 2, and that will equal negative 2 and 2, and those are your vertical asymptotes. Using the asymptotes that we already solved for will help you figure out the domain. The domain of this graph is negative infinity to negative 2, union, negative 2 to 2, union, and 2 to infinity. And the range is negative infinity to infinity, as the graph never stops. Based on solving for the asymptotes, we have an idea of what the graph will look like. So the end behavior of this graph is the limit of f of x as x approaches infinity is 0, and the limit of f of x as x approaches negative infinity is also 0. The graph is odd as it is symmetrical above and below the origin. To determine where the graph is increasing or decreasing, you have to take the first derivative of the equation, and make sure to be very careful with notation, as we all know points will be taken off. Using the quotient rule, we will set up the equation. Y prime equals g x squared minus 4 times f prime, which is 1, minus f, which is x, times g prime, which is 2x, and this will all be over x squared minus 4 squared. The next step is to multiply everything out on the top and then combine like terms. You don't have to multiply out the bottom, as it'll just make it easier later. I removed a negative from the top to make it a little bit easier for myself for the following steps. The next step is to draw a number line. On this number line, you want to put your zeros, which are negative 2 and 2. You then want to plug in numbers that are greater than 2, in between negative 2 and 2, and less than negative 2. Once you plug these numbers in, you'll find out that they are all negative, which then means that the graph is decreasing at all of these places. To find the concavity of the graph, we're going to have to take the second derivative of the equation. We will be using both quotient and chain rules to get our answer. Using both rules, you're going to write out y to the second derivative equals x squared minus 4 squared times negative 2x minus negative x squared minus 4 times 2 times x squared minus 4 times 2x. The next step is to begin multiplying everything out and then combining any like terms. So far, your final answer should be 2x to the 5th plus 16x to the 3rd minus 96x, and this is all over x squared minus 4 to the 4th. Then you can take out a 2x to help you for the next step. To continue, you're going to keep breaking down the problem to make it much easier to find the zeros. As you see here, I have the second derivative equals 2x parentheses x squared plus 12 times x minus 2 times x plus 2, and you're going to set that equal to 0 to find the zeros. So you're going to have 2x equals 0, which is 0, then x equals 2, and x equals negative 2. Just like we did with the first derivative, you're going to want to make another number line, putting negative 2, 0, and 2. You're then going to want to plug in the corresponding numbers above. Once you plug in these numbers, you will find out that the graph has a down, up pattern. For this particular graph, the graph concaves down from negative infinity to negative 2, union 0 to 2, and then the graph concaves up from negative 2 to 0, union 2 to infinity. The inflection point is where direction changes, so on this graph it is at 0, 0. There are no local mins or maxes for this graph. So now we are going to sketch the final graph. So we have our vertical asymptotes at 2, negative 2, and our horizontal asymptote at 0. We have the inflection point at 0, 0,